Hello, Tom from Every Step Calculus, everystepphysics.com. Another problem in Calculus 2 regarding polar coordinates changing to polar coordinates. And here they have this problem is right out of Larson, Hostetler, and Edwards' book regarding the subject. And it's two circles, one within the other, and they give you x squared plus y squared equals 1. Anytime they do that for your tests or your homework, remember that this is really the square root of r. This is r squared. X squared plus y squared equals r squared, and that r squared is radius. And the square root of this number on this side here, the r squared, is for the lower limit of the integral. Like for instance here is the 1. Square root of 1 is 1, of course. And here's x squared plus y squared equals 5. So right away you take the square root of that and put it as an upper limit for the dr integral. Okay? And the order of integration of this integral is dr and then d theta. Okay? And on my programs I do both of them. Let me turn the simulator on here again. And then they come up with a function here. Here's the function here, x squared plus y. Okay, that's actual z. When you graph this, you can do that. You can go to mode and change your. You can go to mode here on this thing, right, on this button right here on the titanium, and it'll come into the function here. You can go to the right here with this cursor and go, and you'll see that it goes to number 5, 3D. You choose number 5 and then do the graphing of it. But somebody comes up with this formula here. All calculus solves nothing useful, in my opinion, after 30 years of studying it. Nothing useful. Not one calculation was in the SpaceX rocket that went off to the space station a couple of weeks ago. Not one calculation in that whole effort. This is a series of puzzles, extremely difficult puzzles like Sudoku, like crossword puzzles. And when you get very difficult, but when you get done with them, you've solved nothing. You've found nothing, you know. Now the double integral finds the volume of these two rings that they have set up for this problem, and then they're finding some volume of whatever this function is when it's graphed, okay? And somebody dreams up the function. Whoever dreamt up the function actually knows there's no calculations for doing that, so I don't know how they come up with it. Just dream it up, and then you're supposed to work at it in a test. But our problem with college and business calculus and all the rest of it is to pass the test and get out of there. Play the game, pass the test, get out of there. You'll never use it again in your life ever, even if you become an engineer at NASA. So, but maybe that's why I don't get any followers. I mean, I got 800, something like 800 subscribers. Always can use more. I'd like to get 1,000 so I could edit my programs. YouTube won't let me do that until I get 1,000 subscribers. Never made a penny off of it, off this, after 30 years. Not one penny off of anybody advertising on it or anything. So I don't know. You can subscribe if you want. It's pretty interesting. But my concern is what I programmed for is that I programmed for me to pass a test when I was 30 years ago and the calculator came out. The TI calculators came out that could solve integrals and derivatives. But we couldn't put the answer down on the page, even though we were allowed to use the calculator. We had to do the steps. But then I found a way of programming the calculator and using what MIT invented and placed, and then TI, I think, either stole it or bought it from MIT to put in their calculators. And I use that program for my programs, for physics and calculus. So let's see how this works here with my programs. Index 8 to get to the main menu. I'm already at polar and double integral because I wanted to save time with the video. I've spoken enough about this stuff. But you scroll down to it and you come, and this is a polar to double integral, so we're going to choose that. Press enter. We're changing polar to a double integral. Here's the polar formula, revolume, because that's what we're finding is the volume. You notice theta 1 over theta 2, radius 1 over radius 2, that's the limits, and we're solving with dr d theta. Now this is if we used the integration of dr d theta. I have in my programs, which you'll see later, where you can do it either way. Like down here on the bottom is try integrating with r dr theta, or see which order is more convenient. So we're going to do that with my calculator, okay? Program. The first thing you do is, if you get it on a test, you're not going to get the answer down here, you're going to get this up here, okay? And you have to somehow come up with the limits. Well, you know the limits is square root of 1 and the square root of 5. That's for the dr limit. And then we're going to change that to polar. So you write this on the side of your paper. X equals r times cosine of theta, and y equals r times sine of theta. And then dA is equal r dr d theta. Or if you use the other integration, it would be d theta dr, okay? More nonsense, more useless nonsense, okay? Yes, I know calculus, but I'll tell you I don't believe in it at all. I don't believe in it. And you got professors on YouTube teaching you like, oh my God, wait till I teach you this stuff. Boy, you're going to really be smart after you do this, you know, and you're really going to go on with your degree, and oh my gosh, so necessary. Baloney. So let's do it. You write this on your paper, you get 2 or 3 points. Remember, calculus and physics the tests are scored on partial credit in the class curve. I mean, I got an A in a physics test one time when I got a 26 on it. Got an A in it. That's how difficult these tests are. But thank God I didn't have any person from India or in my class, because they study this stuff from the age of 3. They know this stuff up and down, and they'll screw up the whole class curve, you know. And you'd know it too. Like, for instance, it's take me to program the calculator for this stuff here, mainly to keep the stuff on the screen of the calculator. It's taken me 3 weeks, every day, 3-4 hours a day, to program this so it stays on the screen. You can read all the problems all the answers in the screen and all the steps. Okay, it's not easy. Every single problem I do, I have 20,000 pages or more. Every problem. This one here, I had to do a full page of my own handwriting of how to solve this, because you'll notice they use a lot of tricks in here when they're talking about, they use factoring and without telling you what they do, and so you have to figure out what they are doing with it. I can't do that in my program. I have to do every step properly, okay? So I do a page of it, and then I program the calculator. I've already entered the function and the stuff in here to save time. Here's x squared plus y. And I always give you a chance of changing the function in case it was wrong. You can enter any function in here if you want. That generally within tests it'll work. And anytime you have a single x or a y in a problem, you have to replace it with what I showed you before in the previous screen. You know, r times cosine of theta or r times sine of theta, depending upon whether it's x or y. So here we are as our function, and we're going to and we've replaced x. We played the x with cosine squared r squared, and then we replaced the y with r sine of theta, r times sine of theta. The calculator switches it around, but that's what we actually did. Order of integration, we're going to do this, the dr d theta one first, Actually, we're going to do the other one first because they did that here. In this, they switched the order of integration here to d theta dr. You can see d theta dr. So we're going to choose number 2 here, which I've programmed. When it says busy here, it's loading the program. And we're going to do from d theta to dr. And here we set up the formula for that. Here's the actual formula for it, R1 over R2 and theta 1 over theta 2, because we're doing d theta. When you do d theta, or it's the first one here that you're using, the first integral here of f over xy, which is z. And we're going to enter theta 1 and theta 2. And we do that for each one. So we got d theta, theta 1, theta 2 is 0 and 2 pi, just like it is right here, 0 and 2 pi. Here's for theta, okay? And then we're going to say it's okay in case you made a mistake. You're going to enter these yourself now, and when you do that, you have to press alpha first. For instance, you press alpha and then put in R1 here, which is R1, which would be 1. You know, I would show you how to do that, but I'm afraid the simulator will screw up if I do that. But anyways, your calculator won't, that you have in your purse or school bag. So we added R1, R2 here, 1 and square root of 5. Here's 1 and square root of 5, okay? Say it's okay. And we're going to set up the integral. Here's 1 and square root of 5. Here's 0 and 2 pi. Here's d theta dr. Okay, so this is all compacted in one screen for you, which is the difficult part of programming. And so z, and we're going to multiply this always times the r. They don't show you that in here, but that's what they did. There's an r dr d theta, right? There's an r here. So they sneak it in and multiply it times r. You have to do that on every problem. So you have to take the function, after you convert it to polar, you have to multiply it times r, which I've done here. Turns out to be this sine of x squared and x cubed here. And we're going to integrate with respect to theta. And when we do that, here's the answer. Write this on your paper, all this stuff, exactly as you see it. And then we're going to use the upper limit and the lower limit to evaluate this d theta integral. So the upper limit is 2 pi, so the answer of that, when we do the integration, after the integration, we solve this for theta, and here we come r squared equals theta times r minus 1, just like it says here. You write that, they have it here somewhere, probably pretty close, but they use weird mathematics to do that. Not weird mathematics, but it's just unnecessary, or how this professor did the problem using factors, and this is how the calculator does it. Now we do the lower limit here of 0, and the answer is r minus r squared. We subtract upper minus lower, subtract upper here minus the lower, and we come up with pi r cubed. There's pi r cubed here. And that's going to be the second integral, the dr integral. So we put the limits in here, 1 and square root of 5, and r times r cubed dr. We integrate over the upper and lower limit, square root of 5 and the 1 here. Here's the integration of the r cubed section here. This is the integration, and then we do the square root of 5 over that. Square root of 5 over that turns out to be 25 pi over 4. And we do the lower limit of 1, turns out to be pi over 4. We subtract them, come up with equals 6 pi, which is what they've got down here. Okay? So we can go back now. We can do the press new problem, but we'll use the same problem. I'm going to use the same function. Okay. And we, of course, do the same thing. We're changing the polar, just like we did here. And we're going to use number 2. Oh, no, we did number 2. We're going to use number 1 now, which is dr d theta integration, order of integration, okay? There's the volume formula again. We're going to set the limits. I'm going to go quickly through these to save time on the video. And then we're setting up the integral here. Except the dr is in the first position here to integrate first. And we multiply times r, come up with r times cosine of theta squared and r sine of theta, and we integrate with respect to r. That integration looks like that. We put these off to the right of the problem, you know, over here on the right. This is what we have left to integrate with d theta. At r2, which is the upper limit, square root of 5, the answer is this here. You can say doing it this way is more complicated, more tedious. At the lower limit, turns out to be this. We subtract the 2, and turns out to be this. Pretty complicated, but all nonsense as far as I'm concerned. But I mean, so we have the new integral of this here. We're going to do the new integral. So try integrating this. Can you integrate this? I can't. I can't. The calculator can. I'm not going to waste my time on this stuff. No way. But we integrate it with respect to theta, and here's the integration. You don't have to put the quotation marks in. I do that because it's of the way I have to program it to keep it on the screen here. Otherwise it would be way off on the screen, way over here, the answer. I have to separate it and do it that way. And theta, upper limit is 2 pi. We do that. Turns out to be 5 times square root of 5 over 3, etc. We integrate at 0. Turns out to be this. Reason I do this is that this is the real one, and then of course the calculator was supposed to be the approximation of it, but I leave it in for that. Upper minus lower limit is here. This upper limit minus the lower limit. Put that on your paper. And turns out to be 6 pi. We do that. 18.8 cubic units. So, quite a complicated problem. You'll never get this on a test because everybody would flunk it. Nobody would get it. And so they don't put these kind of problems on tests, but they put them in your book for you to study it. How long would it take you well, it's taken me 3 weeks to study this problem. I could probably do it without the calculator, but 2 weeks from now I couldn't, you know. And of course you can take my calculator in any test and you'll pass the calculus test with it, or physics test. It won't get every problem right because there's 10 million functions that they could dream up, but any test problem, it'll come up with enough for you to get points on it, and for you to get the correct answers, and for you to pass your test and get out of there without studying for hours and hours and hours. And how many hours do you need to study that you think that you've got this, you know, that you're ready for whatever they're going to give you? It's an insurmountable amount of hours to study this stuff, believe me. You even change a minus sign in it. For instance, if this was x squared minus y, try it when you buy my programs and install them. You can try it. See how different it is. See how it changes everything in life when you change a minus sign in calculus. Difference of squares, you know, x squared minus 9 squared, you know, which is when you factored x plus 3 and x minus 3. Put a plus sign in a difference of squares and see what happens. You can't even do it. The calculator can barely do it. However, MIT is incredibly brilliant, and they did all this for the TI, Texas Instrument Company. Unbelievable. I've never found it to make a mistake, no matter what integral or what derivative it comes up with. So I want to research that and find out how they did that, because it's just unbelievably genius, you know. So anyways, go to my site, buy my program. If you want to subscribe, go ahead, you know. Sure would help me. Thank you. And look for other things that I can bitch about in calculus, and yet show you how to pass your test with this my fabulous program. I'm the only one in the world that does this out of 8 billion people. So I'm not the only one that could do it, but I mean, I couldn't even really train anybody how to do this in my business here, you know. So I'm the only one that does it. They have calculus made easy. He called me up when we first were programming, and asked me how I did my programs, and I told him what I wanted to tell him. And I think that person that made calculus made easy for and physics made easy for the TI side. I think he worked at TI, Texas Instruments, and then they did that. But they do too much teaching in their problems, and so a lot of people that buy calculus made easy buy my programs and finally get to some sane solution of how to solve these things step by step to get through a test. You don't care about learning this stuff. All this, to learn all this, what are you learning this garbage for? Why would you ever learn this? Why would you ever retain it in your brain? Huh? Why? It's nonsense. So anyways, go to my site, buy my programs, and pass calculus or physics. Have a good one.